first thing we're going to do, because we need to find the radius of convergence, is we're going to do a ratio test. So if you remember, the ratio test means that we're taking the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. So in this case, that would be x to the 2 times n plus 1 over 2 to the n plus 1 factorial times reciprocal 2 plus 1. Okay, so from here we can simplify. So we can say that this equals the limit as n goes to infinity. This is the same thing as x to the 2n plus 1 times x squared over 2n plus 3 times 2n plus 2 times 2n plus 1 factorial times, again we have 2n plus 1 factorial, x to the 2n plus 1. So these cancel, and what we're left is the limit as n goes to infinity of x squared over essentially 4n squared. And we can see that as n goes to infinity, this whole thing is going to go to 0, which is less than 1 for all values of x. So that means that the interval that the series converges for all x. So for this problem, we're asked, this is the power series representation of which function? So already we can see that this 2n plus 1 factorial and the negative 1 to the n, that looks like sine. And we can manipulate it a little bit so that it fits in that category better. So the first thing we want to do is we want to make this 6n plus 3 so we can turn that into a 2n plus 1. So we're going to take the x squared out. And so that makes this 6x to the 6n plus 3 over 5 to the 2n plus 1 times 2 to the n plus 1 factorial. Okay, from here, we can see that this is the same as this, just times 3. So we can rewrite that again as x cubed to the 2n plus 1. Because when you multiply 3 times this, you get 6n plus 3. So now we get this. This is the same, so we can put these together. So we should see that right here, this fits very nicely into the representation for sine of x. And so instead of having sine of x, we have sine of this right here times x squared. So all we're going to do is now this is x squared times sine of x cubed over 5. So for this problem, we're asked to find the first 3 terms of the function f of x equals 7 over x to the 4th about x equals 1. So to find our general term, it's going to be some constant times x minus a to the nth power. And to find this constant, we're going to need to derive it by using the nth derivatives at a, which is in this case 1. So the 0th derivative is just f of 1, and that's going to be 7 times 1 to the negative 4th power, which is just going to be equal to 7. The first derivative at 1 is going to be equal to negative 28 times 1 to the negative 5th power. That is just negative 28. Now we're going to find the second derivative at 1. And that's going to be 140 times 1 to the negative 6th power. And that's going to just be equal to 140. Now finally, the third derivative at 1 is going to be negative 840 times 1 to the negative 7th power, and that's just negative 840. So now we have this part, this top part of this equation for c sub n. So that's the first part of our constant, and all we have to do is put it over n factorial to find this constant. So the 0th term is just going to be f of 1, and that's going to be equal to 7. And as we go on to our first term, we're going to say plus. We have this negative 28, which is the first part, over 1 factorial times x minus a to the first power. Our n equals 2 term is going to be 140 over 2 factorial times x minus a to the second power. And our third and final term is going to be negative 840 over 3 factorial times x minus a to the third power. And this a is just going to be 1. So to simplify this just a tiny bit, we have 7 minus 28 times x minus 1 plus 140 over 2 times x minus 1 squared minus 840 over 6 times x minus 1 to the third power. And that is our third degree Taylor polynomial for 7 over x to the fourth power. Use a series to find the limit as x goes to 0 of e to the x minus 1 all over x squared. So the first thing we're going to want to do is we're going to take this e to the x and we're going to write out the series expansion for it. So we have limit as x goes to 0. Now we're going to take this e to the x and we're going to start writing out terms for it. So that's going to be equal to 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus ... And this should just be memorized because it is the expansion for e to the x. And then we're going to have minus x minus 1 all over x squared. So already we can see that we're going to have some cancellation here. So we have this negative 1 cancels out. So this 1 cancels out because we have negative 1. And this negative x cancels out because we have a positive x here. So those two cancel out, and we're left with limit as x approaches 0 of x squared over 2 factorial plus x cubed over 3 factorial plus ... over x squared. So the next thing we're going to want to do is we want these to cancel out, because right now we just have a 0 over 0, which is, we don't want that. So we can take an x squared out of the top. So we're going to say x squared times 1 over 2 factorial plus x over 3 factorial plus ... over x squared. Now these will cancel out. So now we simply have limit as x approaches 0 of 1 over 2 factorial plus x over 3 factorial plus ... Now all of these terms will have an x in them, so all of these terms are going to 0. So all that we're left with is 1 over 2 factorial, which is just the same as 1/2. The first part of this question asks us to find the third degree Taylor polynomial for f of x equals sine of x at a equals pi over 3. So in order to find this, we're going to have to derive the nth derivative at a. So the 0th derivative is just going to be f of pi over 3, and that's going to be equal to sine of pi over 3, which is the same as square root of 3 over 2. The first derivative, cosine pi over 3, and cosine of pi over 3 is 1/2. Second derivative is going to be negative sine pi over 3, which is going to be negative root of 3 over 2. And the third derivative is going to be negative cosine pi over 3, which is going to be negative 1/2. So there are our 4 terms, the basis of building our terms. So we're going to have the f of pi over 3, which is square root of 3 over 2, plus 1/2 times n factorial, but this is 1 at this point, times x minus pi over 3 to the first power. Second term, the second power, and then our last term is going to be 1/2, and then 3 factorial times x minus pi over 3 to the third power. For this one we're going to want to use Taylor's inequality because we want to discuss the accuracy of the approximation on the interval 0 to 2 pi over 3. So I'm going to quickly write out Taylor's inequality, also called Lagrange error. And this m is going to be the absolute value of the n plus 1th derivative at x. So we want to find where this is at its max. So in order to do that, we're dealing with n equals 3, because if you remember from the last part of the problem, we found the third degree polynomial. So we're going to be dealing with r sub 3 of x. So we're looking for the n plus 1th derivative. So we're looking for the 4th derivative. And the 4th derivative is just going to be, if we want to just do that in a little sidebar. This is going to be sine of x. So since we know that sine of x is never, the absolute value of sine of x is never going to be greater than 1, we can say that our max value is 1. So if we put that into the inequality, we have 1 over n plus 1 is going to be 4, so 4 factorial. Then to find this x minus a, we're going to use our interval. So I'll just rewrite that over here. So since we're finding it centered at a, and I'll remind you that a equals pi over 3, we are going to be finding x. Let's subtract pi over 3 from both sides. So this is going to now just be pi over 3. It's going to be negative pi over 3. And this is the same thing as saying the absolute value of x minus pi over 3 is less than or equal to pi over 3. So we can just plug in pi over 3 for right here. So we'll say pi over 3 to the 4th power. So now it's just a matter of plugging it into your calculator, and since this is a calculator problem, you guys will be able to do that. And you get that this answer is equal to 0.050. So that is the largest error you could make when you use 3 terms on the interval 0 to 2 pi over 3.